Today we'll be talking about the key features of polynomials. So we've already done this with quadratics. So now we're going to be looking at these polynomials and answering the same kinds of questions. So remember, domain is the input. And as long as we have the arrows, right, we know it's going to be all of the points, negative infinity to infinity. The only time that changes is if it's in a word problem and we've changed the parameters of the problem. So the range. So this is a low point here. The lowest point we see is -7. So we're going to start with -7, and -7 is included. So remember, when we do our interval notation, equal to gets the square bracket. So from -7, and then it goes all the way up to positive infinity forever. What are the x-intercepts? So the x-intercepts, right, are the points where it crosses the x-axis. So we see we have a dot at -4, 0. We have a dot at -1, 0. We have a dot at 1, 0. And we have a dot at 4, 0. So there are 4 x-intercepts of this function. The y-intercept. So the y-intercept where it crosses the y-axis. So that would be at 0, 2. Now here's a word we didn't see exactly like this before. We saw what is the max or what is the min. Now I'm saying what are the relative max/mins, and it's plural. So there can be multiple answers here. When we say relative, we mean, so a relative max is a point that's higher than anything else near it. It doesn't have to be the highest point on the whole graph. It's just higher than everything to the left and everything to the right immediately of it. So a relative max could be this point right here, because to the left of it, it went lower, and to the right of it, it went lower, right? Even in that moment, it went in both directions. So a relative max would be at 0, 2. For the minimums, there's multiple, right? It hits a low here because it was higher and higher there, and it hits a low here because it was higher and higher there. So we have a relative min at -3, -7, and at +3, -7. So increasing and decreasing. So left to right, we start by going down, then it switches to up, then it goes back down, then it switches to up. So increasing from x is -3 to x is 0. And from 3 for forever, 3 to infinity. Where it's decreasing, going down, it started and went all the way to -3. So it started at negative infinity, went to -3, and from 0 to 3. And then positive and negative. So where is f of x greater than 0, and where is f of x less than 0? So I could see we're above the graph here, then we're below the graph, then we're above, then we're below, and then we're back above. So it's positive in this area here. So that's from negative infinity to -4. It's positive again in this section, so from -1 to 1. And it's positive again, starting at 4 to infinity. And where it's negative was between -4 and -1, and between 1 and 4. So let's do another one. We're not going to answer all the things, right? There's just 4 things we're asking here. Increasing, decreasing intervals, where it's positive and negative. So for increasing, decreasing, right, it was up, then it was down, then it was up again. So increasing was negative infinity to -1. And started again at x is 4.1 forever. And then decreasing was starting at 1 to be at 4.1. Positive and negative. So it's negative all down here. It's negative all down here. It's negative all down here. And then it's finally positive up here. So what we're going to look at, it starts being negative I'm going to do negative first. It starts being negative all the way over here at negative infinity. And then it actually hits 0. So it's not negative here anymore. So we're going to say it went from negative infinity to positive 1, right? Positive is one where it changed. But then it was negative again, starting at positive 1, all the way up till we hit 6. So even though it overlapped at 1, neither one was equal there, right? Neither one was negative under there. It was equal to 0. So we're not putting the boxy bits. We're saying up to 1 and then starting again at 1. But 1 is not included in either answer technically. And then it was only positive from 6 to infinity. All right, so you just have to be careful, especially when it's talking about positive and negative. As soon as it hits the graph, if it's bounced, that's a separate area of being negative or a separate area of being positive. So here's one for you to try. You can pause. Answers are posted in the blank notes on Google Classroom. All right, so example 3, we're going to graph using Desmos, and then we're going to identify these key features. So I'm going to pull up my Desmos, and I've graphed it here. So we wanted the y-intercept. So the y-intercept, I hover there, I see 0, negative 7. So we can say 0, negative 7. The zeros are next. So the zeros, where it crosses the x-axis, we have negative 2.38, comma 0, and 1.91, comma 0. Negative 2.38, comma 0, 1.91, comma 0. And then relative max and mins. All right, I know we have both, so I'm going to write max, I'm going to write min. So a relative max, so I see a high point right here. So 0.33, negative 6.2. Negative 6.20. The minimums, I see a low point right here, and I see another low point right here. So that would be negative 1.55, comma negative 22.43, 1.22, comma negative 8.38. And that's all we have to do. So you would just type your function in to Desmos, right? Desmos.com, and then click on the graph so you could find those points. So here's one for you to try. You can pause or end it here. Oh, I lied. Looks like we're doing one other thing. We're not going to end it here. Yes, we are. I don't know why I'm lying to you even again. I'm so sorry. I have more stuff in my notes that I don't have in this this file. So we are going to end here. This is the end of the key features of polynomials.